What up, everyone? Rusty Rob here. Welcome to another video. And today we're going to be doing Advent of Code Day 15. And we got some flowers in the video here, so that's nice. I hope you enjoy that. So we're going to go through some pretty awesome Rust code. We're going to be using structs. We're going to be implementing a trait. We're going to be using a bTreeMap. Super fast, efficient, auto-end solution. So let's get into it. So today's problem, you're given a bunch of sensors. And for each sensor, you're told what is the closest beacon. And so that gives you a diamond shape which rules out where any other possible beacons could be. And so the question is, for a given row, how many places are there where a beacon could be hidden that isn't seen by any sensor, because the sensor only picks up on the closest beacon. So for row 10, for example, they have row 10 is like this. And so the answer is that there are 26 positions where the beacon cannot be present. And when I solved this, I kept getting 27. I couldn't figure out why am I getting 27 instead of 26. And it turns out the beacon, you can't have two beacons in one spot, obviously. So yeah, there's actually only, you have to subtract one from 27 to get 26. Anyway, let's get into the code quickly. So when I ran this, I got the correct answer. I calculated a bunch of intervals, added those up, and subtracted one. Got the answer. There's only 1 point on the actual row, and we want to do this for row 20,000. So the input is given like this. So it's a bunch of XY coordinates. So we're just going to grab those up with a regular expression. So let's just check this in presentation mode. So yeah, there's only 4 numbers on each line, so it's a pretty easy regex. If I open cargo.toml, you'll see I've just added this regex library. Yeah, we'll get into this code in a bit. So let's go through the main method. So yeah, we're setting up our regex, which is just looking for one or more digits. And in previous videos, I used input.split on the new line character, but I've seen there's this lines method, which just uses a split terminator and things like that. So that's pretty cool. And to get the numbers, which is a vector of I64, we just use our regular expression and use this find iter method where it iterates over the line all the matches. For each match, we're just going to have that as a string and parse that into an I64, and we'll just unwrap that. Our program will blow up if the input's not valid, and then we'll just collect that into a vector of I64. Then we build our sensor from the first 2 numbers and our beacon from the last 2 numbers. And so we're able to do that because I've implemented this from method for point. So there could be thousands of different things we might want to convert into a point. So this from trait is quite powerful, and you can see that up here. I've just implemented from for a slice of I64 for point. So, I mean, maybe a bit overkill for this toy problem, but it's a bit of fun playing around with Rust traits. And you see here we've got our point struct, which drives debug, so we can print it out. And then I also derive these 3 because I use it in a bTreeMap later on. Actually, maybe you don't need it for that because it's comparisons, but I was using it in a hash map at one point. And then we'll get the Manhattan distance, and we're not really worried about overflow here because the numbers aren't that big. So yeah, so we've got our 2 points. We're just calculating the distance of the beacon from the sensor, and we're calculating the dy gap, and we'll use that for our calculations. That's just yeah, I guess the height away, the row is how far the row, relevant row, so we're looking at row to million. That affects our calculation. So we calculate the left is just the sensor's x point and subtract the distance, and then we add the dy height. Just look at that quickly. So if it's this one, for example, and the distance to the beacon is, let's say it's 7, for example, then we go across 7. And then each time we go down a row, we have to add 1, and so on. And say the row was this one here, then that would be the left point of an interval, and then would also have the right point of the interval. And so for the right, it's a similar calculation, and yeah, the left has to be less than or equal to the right hand side. And then we just add that interval. And then if the beacon's sitting on the actual row of interest, we need to store that as well. And I think I'm just using a hash set of points for that. And then our answer is just how much overlap these intervals have, and subtracting how many beacons are already on that row, and that's the answer. So that's pretty cool, and this overlap method's pretty efficient. You can do this in a number of different ways, but I thought it'd be a good chance to use a bTreeMap. So for the left and right point of each interval, like each left point, we just increase. We just add 1 to the bTreeMap, and for the right, we subtract 1. We have to go +1 because we don't want, imagine if we had a start point and an end point on the same, they'd just cancel each other out and we wouldn't know that there was something there. And so yeah, if we just iterate through those points from left to right, every time the count goes to 0, keeping track of the total count, then it'll go to 0 every time all the intervals close, and it will be positive whenever there's an interval present. And so each time it goes to 0, we want to look at when it previously was 0, and that'll give us the length of when it is like the hashes that we're looking for. So you can see we just grab the previous x value. It's just an optional I64. And here we just take that difference and add it to the count and return that. So that was a pretty cool problem. Hope you all enjoyed solving that, and see you in the next one. Enjoy your weekend.